Oliver Morton, the author of the book, is actually a reporter, so his writing style is kind of a narrative that goes through the history of many of these things, including important characters who are worrying about wheat production and feeding the world and so on, and then how Haber-Bosch process came along, and how the evolution of agriculture with Borlaug and Rockefeller Foundation, which worried both about feeding people with agricultural improvements and controlling populations, was funding both sides of the issue and so on. Whereas my tendency is to jump into finding data to go through the narrative of what we are doing to the nitrogen cycle, and in other chapters as well. So please read the book to get this nice narrative that is put forth by Oliver Morton. Okay, so coming back to human use of nitrogen fertilizers, anthropogenic nitrogen contributions in teragram nitrogen per year from 1900 to almost the present can be looked at in terms of natural global nitrogen fixation here, order 150 or 170 or so to 300 teragram carbon per year. And then there is terrestrial nitrogen fixation, which is also natural. And here is anthropogenic nitrogen contribution. So we have gone beyond what the land would do by itself, well into the ranges where the global nitrogen fixation is. So it's a pretty massive perturbation, and we'll see that this cascades through all components of the Earth system, as we said. Looking at some of the data of the world population with and without synthetic nitrogen fertilizers. So once the industrial production of ammonium was well established in Germany and then rest of the world, obviously the world population that's supported by synthetic fertilizers has grown substantially since the so-called Green Revolution through the 60s and 70s, which allowed countries like India to avoid mass starvation and so on. And there is still a substantial portion of the world population that's supported without synthetic fertilizers, but that's not because they have a choice necessarily, or that they are trying to be environmentally friendly. The other argument that is always combined with increased fertilizer use and the increased crop yields and crop production that came along, that I'll show in the next chart, is that the world population grew super exponentially over the same time from the 1950s onwards after the Second World War. You can see that we went from about less than 3 billion to now well over 7 billion, and the projections vary. Some say we will reach 10 billion by 2050, but there are many indications that fertility rates have already saturated, and population growth rates are even flattening in some countries, in the sense of less babies having been born this year than the last, and so on and so forth. So the question I mentioned before about whether nitrogen fertilizer production has actually allowed the population to grow and create all this stress on the planet, biodiversity, ocean, land, and resources, or is it that the population was going to grow anyways because that depends on other factors of, let's say, medicine allowing people to live longer, child mortality going down, and then even if there was no nitrogen fertilizer, would people have just grown more food by, let's say, taking more land for agriculture, and so on. So all kinds of heuristic arguments can be made. Nonetheless, nitrogen fertilizer use per hectare of cropland in 2017 is shown here. You can see that the rich agricultural countries with industrial agriculture take up quite a bit of nitrogen fertilizer. There is more intense use in some European countries and Egypt here, some South American countries, and of course China, India, Pakistan, and the this must be Vietnam and so on and so forth here, and Korea, Japan, etc. Right? So obviously fertilizer production is also going up, has gone up continuously. So just looking at nitrogen fertilizers in terms of millions of tons, and others like phosphate and potash have also gone up, but obviously nitrogen fertilizer completely dominates the fertilizer production. And looking at its impact on crop production, it's not just cereals but also fruits, vegetables, oil seeds, and various other things. Few things to notice here. From 1960s onwards, cereal production has gone up very nicely in terms of percentages, more than 200%. This is almost 250 to 300% increase. In the meantime, the cereal yield has also gone up 200%, which means that per hectare the tons of cereals produced has gone up because of fertilizer use and of course few other things like irrigation technologies and so on. And there is the population growth to go with it, and this is seen as more and more cereals being produced over similar amounts of land, which means that we have become much more efficient in producing food along the way. So the use of land for cereal production has not gone up, but cereal production and cereal yields have gone up. So this is a somewhat of a good news. But in the meantime, ammonia is a very energy intensive chemical to produce. So the synthesis of ammonia through Haber-Bosch process is the source of nearly all nitrogen fertilizers. On a worldwide basis, natural gas and other hydrocarbon feedstocks such as coal, mostly in China, are used. So looking quickly here, you can see that natural gas is almost 65%. There is coal here, but China is special here in terms of its coal use with anthracite and other coal forms. This is for energy production for making ammonia. And how much energy does ammonia sector consume compared to other pulp and paper and non-metallic minerals, refining, iron, steel, cement, and so on, chemicals including feedstocks? Fertilizer is here at 1.2%. So it is a substantial fraction, depends on how you look at it, but it is a good chunk of the energy use just to produce fertilizers, which means we have to also look at the emissions that would come from the whole fertilizer use and the related food production system. So here is the global greenhouse gas emissions by sector, and energy production obviously is almost 3/4 of it. So energy use in industry is a major chunk. Transport is of course there. Energy use in buildings, but buried in it you have food and tobacco and other food processing industries involved. But energy use in agriculture and fishing is separate here, and agriculture, forestry, and land use is a substantial emitter of greenhouse gases. Within that you have livestock and manure, which also includes fertilizer use, agricultural soils, rice cultivation, crop burning, deforestation, cropland, and so on. In other words, nitrogen fertilizers are not just directly contributing to the cycle of nutrients and chemicals, biogeochemical cycles on the planet, but it has intensified agricultural and food production industry, including livestock, in a way that it is a massive consumer of energy, and it's a significant contribution to the total of greenhouse gas emissions. So we'll look at some details about how nitrogen cycle itself is also affecting the operation of the Earth system, in addition to coming also through its impact on food production to supply all the food that is needed for feeding this growing population. right? So we have to remember when we talked about geoengineering, we wanted to talk about impact on plants, crops, ozone, solar energy, corals, etc. So this is kind of looking at nitrogen production, nitrogen fertilizer use, and its cascade through the Earth system, so that if you consider it as a geoengineering, then you know how the influence of that experiment have cascaded into the system.